Okay. Hello, everybody. My name is Hugh Peterson. I am the product manager for standard imaging for our DoseView water phantoms. That includes both the DoseView 3D that I'll be discussing today, as well as our DoseView 1D. Today, I'm just going to do an overview of the system. If I can get my PowerPoint to go forward. There we go. Sorry about that. Why we come to work each day? We know obviously that cancer affects everybody in so many different ways. And, Standard Imaging, we're very proud to be a leading manufacturer of radiation calibration and QA equipment for your departments. And we want to say, partnering with you in precision, that's Standard Imaging. Just a little bit of housekeeping today. This is going to be recorded, and links for the recording will be sent out to all registrants. So when you get that link, if you have colleagues that you want to share it with who may not have been able to attend today, you can feel free to share that link. The questions, any questions you might have can be entered in the dialog box on the GoToMeeting interface, and I can address those at the end. Just a little bit more about Standard Imaging. We were based in Middleton, Wisconsin, and have been there since, like I said, 1989. We were started, so a little over 30 years now. And we design and manufacture a full suite of QA products for radiation therapy. Our phantoms, our water phantoms, as I'll show you today. Stereotactic phantoms. We have QA software both for machine QA as well as patient-specific QA, and full line of X-ray and ion chambers that anywhere from our very small 0.007 cc microchamber, our A16, all the way up to our farmer chambers, A12 and A19. Sorry about that. As well as a number of spherical chambers going up to a 15 liter A8. So it's a full range, as well as our line of electrometers as well. So let's move forward a little bit. And like I said, today we're going to be talking about our DoseView 3D water phantom. And this is our second generation water phantom. And I'll kind of touch on some of the changes that we made from our original design and what those will bring to the table for you as far as the water phantom goes. But obviously, the objectives of a water phantom are quite broad. But your acceptance testing when you're checking your system, your LINAC versus the manufacturer's stated specs, your commissioning of the LINACs, checking all your energies, your field sizes, your wedges, etc. To accept and get that information and data into the treatment planning system. The annual QA, such as our TG 142 and the AAPM protocols, and then of course, after your preventive maintenance and any kind of repairs or situational changes, periodic checks of beam quality as they are needed. And what makes a good water phantom? Obviously you want something that's highly accurate and very repeatable, something that produces high quality raw measurements that you don't have to spend a lot of time with post-scan processing. Since it is something you're not using on a regular basis, you want reliable hardware that will be operational as you need the system when you pull it out of the closet, if you will, for year after year. It's an expensive piece of equipment, so it's not something that you can easily budget to replace on a regular basis. So you want something that's going to last for quite a while. We've made some inroads and specifications in our system to do just that. You want easy setup. Since again you'd only want to use it on best case scenario an annual basis. You want something that you can kind of familiarize yourself with and not have to kind of relearn the whole thing again. That's something that we have done with our easy setup and our use both in our hardware and our software. And you want that flexibility and compatibility to be able to use any array of different detectors from your ion chambers to diodes, microchambers, etc., and including our scintillation detector, which is a water equivalent small volume detector. It's 1 millimeter by 1 millimeter, our W2 scintillator, that is. You want to be able to utilize it with various protocols, TRS 398 or APM protocols, or various other ones, depending on your region and requirements. And of course, different treatment planning system formats to be able to import your data into those treatment planning systems for your commissioning and your beam modeling. So that's kind of what we do with our DoseView 3D. We wanted to offer you something that is ease of use and comprehensive, but still kind of set forth to be able to do those easily and get your scans quickly and comprehensively. So just talking about our hardware, we've got obviously, like I mentioned, accurate and consistent positioning is very important. We use a heavy gauge extruded aluminum frame for the robot scanning arm system, and that maximizes its rigidity, it simplifies the setup, and it maintains that reproducibility. All our positional accuracies and repeatabilities are within 0.1 millimeter per axis. It allows for a very precise, quick 3-point leveling. And even before the system goes out the door from standard imaging, each system is individually tested on a industrial coordinate system unit to verify not only the performance of the system, but also those accuracies that we specify. Just a few points on our system. Our water tank and frame are mechanically secured together to ensure that long-term integrity. And we have kind of redundant motors, so there's no chance for any cantilevering of the system as it moves through the water. The motors are matched and calibrated together. Have a fully integrated lift cart and reservoir cart with a precision leveling platform and positioning platform. And then we also have an optional lift-only cart that does not include the reservoir. So we have options there as well, depending on your specific needs. And then, nice thing again, since typically you're done with your scanning, you want to kind of move it into storage. We have an advanced suction drain, and what that does is kind of a moat system that sits in the bottom of the water phantom and helps drain any of the residual water out of the phantom, so that your arm and scanning arms are not sitting in any water for the long term while you're waiting for the water to evaporate or clean out the system. So it's little things like that kind of make our system kind of unique. And as well, our uniqueness is included with our precision positioning platform. We have coarse rotational adjustments that lock into place at 90 degrees and at 45. So there's 45s if you want to do your diagonal scans. You can easily rotate that phantom. And the nice thing is it sits on a kind of a self-lubricating, if you will, Teflon platform. So you can rotate the tank even with water in it and lock it into place. So there's also fine adjustment levers that you can see there on the edges of the platform. For once you get the coarse adjustment under the collimator light and the crosshair, then you can fine adjust those accordingly by rotating the levers there. You have an X movement, a Y movement, and then a rotational movement as well. As I mentioned, this is our Generation 2 hardware. We've kind of lowered the profile a little bit of our design. You can still do your 40 by 40 and your depth scans as needed, but we've compacted the overall height of the system to be able to use it in Halcyon units, so it's compatible there as well as your conventional C-arm Linux. And not only did it just compact and make it a little more adjustable, more usable in the Halcyon systems, it's also improved the rigidity of the system as well. Here's just an example of the system in a Halcyon unit, so you can see it fits in there. We've added specific crosshairs for Halcyon on the sides of the tank, as well as fill lines for the halcyon, so you know where to fill the tank to maintain those couch limits, since you cannot use a cart support for the halcyon, because it does have to sit on the actual couch itself. Additionally, we also offer a halcyon compatible brass alignment cap to allow you to get that chamber positioning with the halcyon MV imaging system, since there are no internal crosshairs or internal field lights, I should say, and crosshair wires for positioning the chamber. You can utilize the buildup cap and the MV imaging. With wireless connectivity, not only for our pendant itself, the pendant is wireless, gives you a simple kind of aggravation-free setup. You have onboard displays to show your exact probe position. There's 3 touch button speeds, including the 0.1 millimeter step mode. And a nice feature too is there's actually a bias switch at the pendant. A lot of times, I know if you're at the console and you turn the bias on with the software, but then have to go back in the room, you have the ability to disable the bias at the pendant and not have to run back out. Saves you some footsteps and add some convenience there. And then additionally, the whole system itself can be used either in a wired or wireless configuration, wireless connectivity to the PC for that convenience and versatility. We include both the full cabling system as well as the Zigbee radio for that wireless convenience, and that's certainly up to the user's preference of whether they want to use it wired or wirelessly. We've got a long experience and history with manufacturing electrometers, and we've incorporated some of that expertise into the electrometer for the DoseView system. It's a charge digitizing electrometer and gives you high-speed acquisition. Has a 10 femtocoulomb resolution, dual polarity bias voltages, and those bias voltages are independent. So if you wanted to use for example, a chamber for your reference and then a diode for your field measurements, you can set those biases individually. Obviously, you wouldn't want a bias on a diode. So there's also kind of a little bit of a safety feature built into the system as well. Whereas if you do select a diode in the software, it will not allow you to turn on any bias voltage to that diode, saving any damage to a diode or the electrometer by trying to turn on bias for the diode. Some other nice time-saving and convenience features for the system. We've got a very innovative and versatile detector alignment system. We have a water surface alignment jig, which you can see on the bottom center there with the X and the crosshairs on it. It's kind of a system, a visual system that gives you the ability to easily check your probe position to the water level, and any distortions in that crosshair or the X will indicate to you that the chamber will not be in the correct position. But once you can see, as you have the levels set, noted there by the green circles on the drawing, you have that position set. And then in the upper right, you'll see what we have is a chamber positioning jig, and that chamber holder, the white piece there that's holding the chamber, can be unmounted. It can be mounted and lined to the line with that buildup cap, and then that whole assembly there, the 2 screws lift that off the mount, replace that on the carriage in the Phantom, and it puts that chamber exactly at that point of reference that you had set. So it's very quick and easy to do the leveling and the alignment of the system, even though it is manual. We've kind of looked at some different automatic leveling systems, and technically, while they may seem more advanced, they're still very labor intensive and time intensive, because if you don't get it set up correctly the first time, you have to run through the whole leveling routine again. You don't necessarily get the option to do any fine tuning. you have to rely on the system itself. Where ours, you have the ability to do those 3-point levelings to get your runouts and your depth alignments correct. And additionally, we have automatic fine beam center, and that fine beam center gives you a automatic check. Once the chamber is set, you can hit the fine beam center button in the software, and it will run the chamber out to the 50% lines of the beam and find those 50% lines, and then give you any required shifts to center that chamber. And you can do that at multiple depths to check your leveling as well. It's very very quick and easy. And all our systems include our X-rated 0.125 cc A28 chambers. Some advantages to our chambers: it's a spherical collecting volume, so whether you're in plane or cross plane measurements, there don't have to be any adjustments or processing of the scan data. Because of elliptical collecting volumes, our spherical volumes are identical for cross-plane and in-plane measurements. Our chambers are homogeneous Schanke C552 conductive plastic, and that includes the collector guard and the shell. So they're very robust. They're not fragile like a graphite shell chamber are. And they're also almost pretty much invisible to the beam because they are all plastic construction. There's no high Z material in the construction of the chambers, like for example a copper collector, things like that. So basically being homogeneous to the beam and to the manufacturer, you don't get any beam perturbation from our chambers. And because they are all conductive plastic, they are a more robust design. We've got a 5-year chamber warranty for our chambers. There's no graphite in the chamber. There's no dag coating that can flake off over time. We've got chambers that have been out in the field for 30 years and are still being used on a regular basis. And then we also have a complete offering of X-ray detectors, from our ion chambers, like I had mentioned, from our small micro chambers to our large volume spherical chambers. We've got a couple of diodes, both a vertical and a horizontal orientation diode for stereotactic, as well as our W1 and W2 scintillators, which are a water equivalent scintillation detector for scanning. And another nice thing about our system is we have user replaceable components. Our motors, our motor control, our motion control units, our cabling, power supplies. Those are all field replaceable by the user itself, or we have support personnel also. But the nice thing about being user replaceable is we can get those parts out to you right away should something come up. Typically, we don't have a lot of issues with our components. We've had a couple instances in the past where someone had set up a diagonal scan incorrectly and irradiated a motor, but that was taken care of very quickly and easily and replaced in the field. So we have taken new instruction sets in the manual and alignment crosshairs on the water phantom to help alleviate that as well. Now moving on to the software. With the software, we've got a very easy left to right, top to bottom navigation. We rewrote our software from the ground up a couple years ago and have just actually entered a new version that's going out for release probably in the next week or so. And now we're already working on the next version to add new functionality to it as well. But it's easy left to right, top to bottom navigation, like anyone who uses any kind of Windows environment is used to. We like to say there's no hidden features. Everything is right at your fingertips and very easy to use. And all our scan cube setups, our measurement and analysis components are all very intuitive and easy to step through. And I'll kind of show you that in just a second here. And at that, let's take a look at that software, and I'll bring that up. So this is our title screen and our opening screen. And you'll see here we've got the enter the DoseView and then enter DoseView 1D. So the 3D and the 1D, we've just integrated our 1D software into our DoseView 3D software. So you have the functionalities in both the 3D and the 1D environment now. But obviously for this presentation today, I'm going to jump into the 3D side. And you'll see here it's very easy, 4 tabs to get set up. The clinics and machines are kind of self-explanatory. You add those accordingly, your clinic name, your location, contact, etc. Adding machines very easily. This is your specific Linux, so you add those machines accordingly here, serial number, or your SADs, what model you're, and who the manufacturer is. And then energies and DMAX values as well, what you have on those specific Linux. So very easy, very quick and clean. You can edit those, you can archive them. If a machine goes offline and replaced, you can archive that, but you'll always have the data at hand. Same for the detectors. This is basically where you set up your detector names. You enter a name, manufacturer, whether it's our Chambers or Xray, or if you have other manufacturers' chambers as well. The type of chamber, whether it's spherical or, cylindrical or plain parallel chambers. Your inner diameter for doing your dose conversions later on. So that's your detector entry. I'm going to jump over scan queues real quick and just kind of jump into preferences. And this is kind of where you can set your date format and your time format, 24 hours or 12 hours. Your date formats, whether you want month, day, year, or you want that printed out and the weekday, things like that. Decimal separators, period or comma. Obviously in the States we use period most of the time. Elsewhere in other regions, they use a comma for a decimal separator, so you have that choice as well. And then your CSV delimiters too, what separates your CSV points. But then jumping back to my scan queues, this is kind of a nice key feature of our software. One of the things we want to do is make our queue setup very easy for you. So we feel we've done that and get very high marks from users for our scan queue setup. Basically, you have your 4 components here: your general, your energies, your field sizes, and your scan types. Nice thing too, it kind of walks you through. You see they're listed as not set, so I can just put in a name for my scan set. Put a description. I want to do maybe 6 MV. Whether I want to do water or air, obviously you can most of the time do it in water. Not to preclude that you could do it in air if you wanted to. Your modality, whether you're doing photons, triple F, or electrons. And then your field definers, JAWS or MLC. If you have any modifiers, either wedges, or if you're doing electrons, you have cutouts. You can also choose SRS cones. So you've got that functionality as well. And then energies, set those energies accordingly. Like I mentioned, this is just going to, for this demo, do 6 MV. Choose your field sizes. I want to do maybe a 10 by 10 and a 20 by 20. And then I have scan types. And my scan types, you'll see after I choose a couple, I'll get a couple more selections over to the left here. But I want to do cross plane, I want to do in plane, and I want to do depth measurement. So I can go to my depth measurement, and I want to do, let's see, I want to do one at DMAX, I want to do one at 10, and maybe at 20 cm deep as well. And my CAX offsets, if I want to do anything off of the central axis, I can set those up easily. I can, if I want to do 10, I can add that very easily. If I don't want to do 10, I can delete that again real quickly. But I just want to do my my central axis here for this set. And then my scan mode. This is some unique features to it. It allows you to either choose whether you want to do step or continuous. And obviously, step being in millimeter steps, continuous now being in millimeters per second. Number of zones, I can choose this to be a resolution of just 2 millimeters all the way across, or I can choose multiple zones, and this will give me the ability to set up my tails and my flat region to a certain specific resolution. If I want a higher resolution in the penumbra and shoulder region, I can set that as well. Here you have it. So I'm doing 2 millimeter steps in the tails and the central. Then I'm doing 1 millimeter higher resolution measurements in the penumbra region. And I can set those zones, outer and inner zones, to different sizes if I want. And then also choose my overscan distance. If I want to do a specific distance in centimeters, or if I want to do a percentage of my full width half max, I can do that as well. For depth, similarly, I have the ability to do step or continuous. I can also, if for some reason I choose a path that will not necessarily hit a point at Dmax, I can choose to force a point at Dmax, so that will make sure that if I'm at a Dmax at 1.5 and I'm set it at 2 millimeters, but I'm going to be at 1.6 and then 1.4, it will stop and take a measurement at Dmax as well, and then return to that original path. So that's what we've got for force point at Dmax there. But I can save this if I wanted as such. And you can see here I have a total of 14 scans for this set. So, and if I look at my list here, there's my my scan set there. I can easily do copy if I wanted to copy this specific set and maybe change that 6 MV to 10 MV and have another energy set easily without having to go through the whole process of adding the whole set again. If I want to use all the same parameters with the exception of, say, the energy, I can do that. I can edit them, delete them. I can export and import these as well, depending on where you want to do your measurements. So if you wanted to set them up on a laptop, but then move them to the console PC for measurement, you can export those easily to that other PC. Moving on now to the Measure tab. This is where actually we'll do the measurements, of course. You have the machine setup, so that's where you choose your specific LINAC. Your dose rates are pre-configured but adjustable, so there are defaults there, but you can adjust those accordingly. Choosing my detectors, I want my Xray and A28, both my number 1 and number 2 I have set up. You also have the ability to choose not to use a reference detector for some reason. If you were doing, say, cobalt or something that is not pulsed, you can choose not to use a reference detector. Setting up my electrometer, I can turn on my my bias. I set it for my field and my reference. Oh, I didn't connect. Sorry about that. I do need to connect. For this is a demo water phantom. I can set that up, and you don't need to be connected. So if you pull out your software on a regular basis and just want to familiarize with it, you can choose your demo 3D, and that will give you the ability to kind of play around in here, if you will, to kind of practice and kind of reacquaint yourself with the software very easily. But now I can turn on my field and my my reference detector bias at 350. I can zero my electrometer from here. I can set my position. I can move my probe to any position I want here. I can go to any specific position. I can set my origin. I can go to origin. This is all things that you can do on the pendant as well. But once you're out of the room, if you want to adjust things, you can do so accordingly. And then my phantom orientation, that's just how the phantom is sitting under, in which direction it's sitting under the gantry. So now, similarly, all these are blue, and blue denotes ready to go. So I can move to my queue, and I can load my queue. I'm going to load that queue I just set up for the 6MV. This is telling me just to make sure that my dose rates are correct and that their settings are correct for the electrometers. I can zero my electrometer from here. I can set up to normalize to a depth. Run my my scans. I can reload the queue. If for some reason I want to reload this queue and scan it again, you can do that. And then if you want to see what specific points are in that, you can also do that with the detail button here. But I'm going to start this scan, and you'll see the scan starts, and you'll get a green note here, highlight showing you which scan is active and a progress. So while those are running, I'm just going to jump over, for the interest of time, to analyze and kind of show you some of the tools and features we have for the for the analysis page while it's scanning in the background. So I can choose to load some of my specific scans here, maybe some of my 6MV scans and maybe my 6MV depth scans. So I can load those, and those will show on the system here. You've got a full toolbox, if you will, of different filters. You've got a couple smoothing filters, both a boxcar and a Gaussian. You have the ability to edit specific points in the profiles or the depth measurements. You've got a normalized to a specific value. You've got the ability to normalize its center. You have the ability to center the scan. You have the ability to average your symmetric, show an average symmetric value for left and right hand sides of the profile. You've got the ability to mirror in the negative to positive or the positive to negative direction. You have the ability to do a flip of the scan, and then you also have the ability to shift it. The nice thing too is, as I set up a filter, so if I wanted to maybe shift it 2 cm to the positive, you'll see now that it's shifted. I can always show my raw data. So you'll see this is the raw data and this is the shifted data. I can look at my filters here, showing you what filters are set on different specific scans. And now you'll see here now that 2 centimeter shift shows on all these. And you're kind of thinking to yourself, well, why would I necessarily shift it 2 centimeters? So I can actually clear either that last filter or clear all those filters. So now I'm going to go back, and now I'm just back to my raw data. I can export any of this. Oh, so you'll hear that you heard that ding. That's basically telling me that now something, either the scans have finished or there's something that needs attention back in the measure page. And you see here the next scan differs from the current scan due to change in field size. So I'm going to jump back to my measure page, and you'll see that these 5 scans or 6 scans, 5 scans, I guess, or actually 7 scans have completed. And I need to now make my adjustments for my field size, going from my 20 to 20 down to my 10 by 10. That's done, so I can start those scans as well. So now that next scan set has scan group has started. Going back here real quick, so I've got, like I mentioned, showing you the filters, showing you the different metrics. Here you're seeing your flatness and your symmetry, your maxes and your minimums, your penumbra width, their edge, etc. All there available to you. And go to my depth scan, and you can see here you've got similar filters. You have your smoothing filters, your point edit, a couple of different normalization tools, your shift tool, and then you can also perform a dose conversion. So if you want to convert to dose and then export to a PDD table, you can do that very easily. And to do that, you basically just click on that, showing you here your chamber diameter that you had placed in the preferences tab under your detector, and then your chamber drop to get that effective point of measurement will automatically do that. And now you can see down here it's actually converted from an ion curve down actually to a dose measurement. So you've got those functionalities as well. You can export these accordingly to your treatment planning systems. And so if I choose to export that, I can choose my export type, either Variant Eclipse, or to Electa Monaco, Electa's Aqua QA protocol database, Philips Pinnacle, Research. You can export it in DoseView. So like I said, if you want to take these scans from this PC to, say, your personal laptop or something like that, you can easily do that. You can export it to CSV. You can export those PDD tables. You can also do a calculated TPR and export that as well. So you've got all the various different functionalities for export. You can also import. Nice thing too is if you have legacy scans from, say, an older PDW or an IBA tank that you have replaced, but you still have that data and want to do some analysis of those, you can import those legacy scans into the DoseView software as well. And then we also have the ability to export to CSV reports. So So that's kind of just a quick overview. Like I said, this is just wanted to give you an overview today, kind of show you some of the tools, show you how easily the software is to use and run through to get your scans, do your analysis, and things like that. Some of the points on the hardware as well. Let me kind of jump back into and I knew that was going to happen. Let me just go through and get to where I'm supposed to be. Hit the wrong button. But basically, just kind of some overviews of the hardware and software. You know, the hardware very structurally rigid design for very good repeatability and accuracy. It's a very rigid framework to the system, so you don't get any flexing. So you do get that good repeatability and accuracy. All the precision positions are within 0.1 millimeter per axis. It's a very quick system setup. You can fill the Phantom in about 10 minutes and do your leveling and setup in probably about another 10 to 15. We've got a system at the University of Wisconsin Calibration Lab. They use theirs for their LINAC measurements, and the person that does that usually can set this up in about 10 to 15 minutes to be scanning. So it's a pretty quick setup. We've got the wireless functionality for setup ease and time saving, as well as full wired capability. At the fast acquisition dual electrometer with the independent bias, and a very intuitive and versatile detector alignment system as well. All those detector holders that I showed you on that slide are included. So if you want to use our 828 scanning chambers, if you want to use a farmer chamber, different parallel plate chambers, diodes, those holders are all included with the system. Software summary: very easy left to right, top to bottom navigation. Quick queue setup with easy copy and editing functions. Like I said, we have no hidden features. Everything is kind of at your fingertips and visual to you. You don't need to go digging for different functions within the software. You have the choice of either step or continuous scanning with that multi-zone resolution. You have full export functionality to any number of different treatment planning systems, as I showed you there. The import functionality for the legacy scan data from older systems that you may have used in the past, and a very straightforward post scan processing and metrics. And one thing that I didn't mention is, one thing that we found with users of our system, there is very little post-scan processing. The raw data you get out of this is very strong and very good. So you don't have a lot of post-scan processing that's required. But that's kind of all I have today for the overview of the system. And if you have any questions, feel free to visit us at standardimaging.com. We've got a rep finder, so you can find your regional representative there very easily to request any additional information or a quotation if you'd like. Feel free to contact sales at Standard Imaging, and again, that will be directed to the specific account manager that you have for your region. Or feel free to email me at hpeterson@standardimaging.com with any questions you might have. So that being said, speaking of questions, I will jump into the questions. It doesn't look like there's any listed. So again, if you want, we will be sending a link to this presentation to you, so you can feel free to review it again at your leisure. Or if you want to share it with your colleagues who weren't able to attend today, you can certainly feel free to do that. But then again, after the fact, if you have any questions or any needs, please let us know. Thanks very much for your time. I hope you have a good rest of your day, and look forward to hearing from you if you do have any needs.